So with that being said, we like to typically we'll start out class with kind of a warm-up type. We did this yesterday or the day before. We're going to use it today and the next day and all that stuff kind of deal. So today's warm-up is give me a linear equation, okay, in both standard form and slope-intercept form. Now let's do a quick review before you jump into this one. Slope-intercept form. Anybody? Y equals mx plus b. Okay. Standard form. That's that ax plus by equals c, right? What were the three conditions that we talked about with standard form yesterday? Give me one.
It has to be not. It can't be a zero. It must.
What can't be a zero?
A, B, and C.
A and B. C can be zero.
Oh. Okay.
The A and B both can't be zero. That's one. Okay,
Oh.
maybe somebody else give me another one. There's two more. Two more conditions for standard form. Say loud. All integers, no decimals, no fractions. Okay, that's one. What's the other one? It's not so much a condition, it's kind of like the way it is. X and Y on the same side. Okay, right? So knowing that y equals mx plus b is slope-intercept form, standard form, no decimals, no fractions, A and B are on the same, or X and Y are on the same side, and you gotta have an X, you gotta have Y in it. Make me the equations for those, between those 2 points. First thing we should probs do is we should probs find the slope. So let us find the slope between those 2 points. Subtract the y's over, subtract the x's. So that's going to be negative 1/2 is what I got. Yes, for a slope. Okay, so that's good. So I'm a point sloper because then it just works it through. So the point slope form, just the way I was taught. I know that they don't teach it that way anymore, but it's kind of the way that I was taught. It works for me. So y minus, I'm going to go with, let's go with the first one. Y plus 2 equals negative 1/2 times x minus 7. The other one would have been y plus 1 equals negative 1/2 x minus 5. Either way, you're going to get the same thing. So then if I distribute, then that would be y plus 2 equals negative 1/2 x plus 7/2. 2, I need to move that 2 over, so I'm going to subtract 2 from the left side, but in my brain, because I got to have common denominators, I'm going to subtract 4/2 on the right side. 4/2 is still 2. So I'm going to do that. And then that gives me the slope-intercept form of y equals negative 1/2 x plus 3/2. So that's my first one. Then from that, now I got to get a standard form. Well, one of the 3 conditions in standard form was no fractions. So I'm going to multiply everything by 2. If I multiply y by 2, then I get 2y. If I multiply negative 1/2 x by 2, I get negative x. If I multiply 3/2 by 2, I get 3. See what I did there? Multiplied everything in the box, every term in the box, by 2, because I have to get rid of the fractions. The standard form doesn't have a fraction. Then I can add x to both sides, and my standard form then would be that. Questions, comments, concerns, clarifications? Yep. There. Right? Is that good? So today we're going to talk about real numbers. So we're going to do kind of P1 and P3 today. P2 we're going to kind of skip over. We'll gloss over it. You'll see most of those concepts in the throughout the entire chapter. Okay? Just a reminder that no school tomorrow, so no class tomorrow, and then you'll have a formative next week, Friday, and then a test on the 19th. Okay, so we'll test on the 19th for this unit. Okay. Just a refresher. You don't have to write this down, but just a refresher that there's two different kinds of numbers out there. Okay? There's rational numbers and there's irrational numbers. Rational numbers can be written as a fraction. Okay? So any number that can be written as a fraction is a fraction. Any number that can't be written as a fraction is irrational. Then within rational numbers, there's integers. Integers they're just like, they don't have a fractional part to it. Like I don't want to call it whole numbers because that's another subsection. Okay? Integers are just the digits. Okay? Whole numbers then are all the positive integers and 0. Natural numbers are just the positive integers, not 0. But again, you don't have to know that. That's just what we're talking about when we talk about numbers. Okay? Most important concept from this slide: rational numbers can be written as a fraction. Irrationals can't. Okay? Oh no. Just some more examples of it, but again, we talked already about that, so we're good to go with that. Okay? We are going to be graphing things on a number line, and we're going to be representing an inequality. These are for more inequalities. We're going to represent an inequality in one of three ways. Okay? So, actually, let me move this up here a little bit. The first way is we represent it as the inequality. Less than, greater than, less than or equal to, greater than or equal to. Okay? You've seen them before. I'll go back to elementary school when you first learned about inequalities. Alligator, right? You guys learn about the alligator? Alligator is the bigger one. The bigger thing. They're hungry. Okay? So whichever way it opens, that's the bigger one. That's really what it is. Okay? Then we've got possibly a new or not as familiar with it concept called interval notation. It's the same as an inequality. It's just written much nicer and neater and cleaner and prettier. Okay? And then we have a number line graph for it. Okay? So let's take this first one first. Okay? So the the inequality would be x is greater than 3. So I want to represent all numbers bigger than 3. Okay? So that's my inequality. The interval then would have parentheses if we are dealing with less than, greater than. It would have brackets if we are dealing with the equals components. Okay? Parentheses doesn't get infinitely close to, doesn't include, brackets includes. Okay? So we want all numbers bigger than 3. So the 3 would be on the left side because we work left to right, okay? Low to high, and so on and so forth. Okay? Now, in the graph, you would have put a 3 somewhere on your number line, and then you would have said, okay, it's an inequality, so I'm going to go with an open dot because it's not an equals part, and then you probably would have gone up and to the right. Okay? Now, if you're looking in the PDF of the book that we have for this section, they do it a little bit differently because they have the ability to do colored text. Sometimes it'll look like that. Other times, it'll look like this. Where I'll put the parenthesis right on the number line. Okay? So just so you know, if you're looking on, if you're using the supplemental resources that we have, sometimes it looks like that. Okay? These all mean the exact same thing. Okay? The only thing that would change here, the only thing that would change here on this one is now because we're dealing with the equals component, that means it switches to a bracket, which would switch then to a filled-in dot that you would normally be accustomed to. Your text, I shouldn't say your text, the textbook or other people might actually have a bracket there and then going that way. Those both mean the same thing. Okay? Now, in terms of you producing stuff for us, we prefer the maroon method because you're probably just using a pencil. You're not going in multicolor. Okay? So we would prefer the above the line aspect so we can clearly see which way your arrow is going. Okay? Compound inequalities have both, or have two of them, I should say. Come on. Come to me. It senses that my finger is different than the pen. So, compound inequality. Oops, tap the brakes. You would have to put two numbers on your number line. Open and closed. And then we want all numbers in between them. Okay. The alternative would look like that. But again, not a fan of that, especially unless you're using multicolors. You now, get you guys into this one, you come up with an inequality, the interval notation, and the graph for the phrase any number at least 7. You come up with my inequality, interval, and my graph. Would you agree that at least would be including 7? Yeah. Okay. We want numbers bigger than 7, right? At least 7, so bigger than 7. So then that would be an interval with a bracket, 7, to infinity. All infinities, positive and negative, are not attainable. Chuck Norris. So it's that. And then good times. Love it. Gotta get back into thinking about our exponent rules. Okay. So if you look in the textbook, which here, let me get this going. So in your text, in the text that goes along with this class, the supplement, there's all of these. There's these 7 properties of exponents. Okay? You've used most of those properties before, so it's just a matter of remembering them. Remember, with everything, notice everything has the same base. Okay? So if we have the same base and we're multiplying, we add the exponents. Okay? If we have the same base and we're dividing, we subtract the exponents. Okay? Anything to the 0 power is 1. Okay? If we have a negative exponent, we move it to the opposite side of the fraction bar, and it becomes positive. Same exponent, just makes it positive. If we have multiple things to the power, everything gets taken to that power. Power to a power, multiply them. Power to a power, multiply them. Okay? So exponent rules that you've seen before, let's utilize them now. Okay? So if I wanted to simplify these, maybe I can't get them all at once, we'll just do them 2 at a time. Okay? So if I wanted to do these 4, the first thing that I would do is I would look at these 2 separately. So I've got 3ab to the 4th power, all of that squared. Well, the 3 needs to be squared. 3 times 3 is 9. The a needs to be squared. A times a is a squared. And the b to the 4th needs to be squared. B to the 4th times b to the 4th is b to the 8th. Then that still needs to be multiplied by 5, a to the 6th b. Numbers go with numbers. 9 times 5 is 45. A squared times a to the 6th. So if you've got 2 a's, we multiply it, we get 6 more a's. How many a's do we get? We get 8 a's. So we're going to say a to the 8th. How many b's? 9 of them. So it'll be b to the 9th. Negative exponents, we don't like them, so we have to move them. A squared is positive, so it can stay up top. B to the negative 2 power is going to get moved to the bottom to make it be positive. A on the bottom stays A on the bottom. B cubed on the bottom stays B cubed on the bottom. So in your brain, that's what you're doing. Okay? Then you simplify. Now, I've got 2 A's on top. I've got 1 A on the bottom. So that can simplify to just be A. I've got 3 b's on the bottom, now with 2 more b's on the bottom, so that can become b to the 5th power. Some more exponent type things. Okay. If you've got a fraction that the whole thing is taken to the negative exponent, you can reciprocate the whole fraction. And that would make the exponent be positive. Okay. So if you've got a fraction, you can reciprocate it, then that changes the positivity of the exponent. So now then that would become 2 squared on top. Which would be 4. X squared squared on the bottom would become x to the 4th. Questions, comments, concerns, clarifications on any of those variable type ones? Now, when it comes to numbers and exponents, now we can actually start doing some stuff. This top number here is called is the exponent, I should say, in it. It will remain the exponent. This bottom number here is going to be something called the index. When you've got a fractional exponent with a number, the index is going to tell you the root that you need to take. Okay? So this could be rewritten as the square root of 16 to the 3rd power. Okay? Top number becomes your new exponent. Bottom number becomes the root that you're going to take of that number. Square root of 16 is 4. Then we have to cube 4. 4 times 4 is 16. Times 4 is 62. Good. Good times. Side note, if you ever, because sometimes I can get a little long-winded, okay? Because I love this stuff, and I forget that, sometimes I just go and go and go. If you ever need that, like 30-second mental break, just let me know. We'll take them. Makes everything better. Let's get into it. Linear equation. Just talked about this in the Algebra 3 a couple hours ago. What is, when you're solving equations, what's the one rule that we gotta follow? One rule when we're solving equations. Got it? PEMDAS is more of the order of operations. It's what we kind of do first. Close though. What's the rule we gotta follow? Sometimes it may be called golden. Anybody?
Show your work.
No, that's just the Linzmeyer rule. Show your work. Yeah. You guys have done. I know you've done it. You probably just you're experts at it that you don't even think about doing it anymore. You remember? How do we go about to get it to solve?
Simplify.
Yeah, but how do we go about to get it to simplify? I know. What? But how do we go about doing that? You guys are thinking simplifying right now. I'm thinking solving. Simplifying and solving are different. Okay, but how? But how?
With your brain.
But how?
Neuron.
You guys, I don't. This is the best part. Best part is you guys know it. I know. I'm gonna say it here. Why is it? What you do on one side, you gotta do the other. Equations are solvable. Equations are balanced. You gotta keep it in balance. Okay? All this simplification stuff that you were telling me, that's for expressions. Okay? That's not equations. Equations are a balance. You gotta keep your world balanced. Okay? So what you do on one side, you gotta do to the other. Okay? So, first off, we're gonna start off by distributing. Distribute. Okay, so we're there. Yeah. Okay. Now, to make things easier on us, we would simplify, combine like terms, whatever you want to call it, all those different things. Okay? So, left side would become 7x minus 3. Right side stays 5x plus 2. Now, here's where the golden rule of algebra comes in. Okay? What do I do next? Subtract 5x on both sides. So whatever I do on one side, I got to do on the other. What's my other option?
Subtract 2.
Subtract 2 from both sides. What's my other option? We could add 3 to both sides. What's my other option?
Add 7x to all.
Do I want to add 7x to both sides? Why not? We want to subtract 7x from both sides. Yep. Okay? So we've got 4 options there, right? Because it doesn't matter which side our x's end up on. Which side our numbers end up on. Now, you guys are advanced enough where you can do those two both at the same time. Okay? So that you can jump right into 2x equals 5. Then divide by 2. Now, I hate to break it to you. I will be the bearer of bad news today. And I can already sense the groans that are going to come out of my mouth. Or after I say this. Notice my answer.
You can't use decimals.
You're not going to want to use that. This class is a fraction class. Okay? Everything that we do is fractions. Just look at the unit circle. Everything on there is a fraction. Okay? Everything's on there as a fraction. You're going to want to keep things in fractions. Now, sometimes, is the problem given to you without fractions, or that you can't get fractions? Yes. Okay? But if, like here, 5/2 is much nicer, much cleaner than 2.5. No, to everybody in that, including you. Because you want that, because that's going to make that easier. Okay? Right? Can't be scared of fractions. You're beyond the point of, oh, fractions, I don't like them. You have to like them. Because you're going to get to that in about a month and a half. Solving linear inequality. Now the only thing that's different is we've got this inequality. Still, what we do to one side, we do to the other. That golden rule still applies. The only thing different with inequalities is we add one more rule. And that rule that we add in is that if we multiply or divide, I'll put it down here. Come on. If you multiply or divide by a negative number, you have to flip the inequality. So a less than becomes a greater than. A less than or equal to becomes a greater than or equal to. Okay? That's our extra rule. So go through, distribute, combine your like terms. That's all great, grand, and wonderful. I'm going to add 1 to both sides. I'm going to subtract 5x from both sides. That's going to give me negative 2x is less than 7. Now, when I divide by a negative 2, I'm sensing that. So this then would become in inequality form. This would become x. Flip the sign to greater than. And then we can keep it as negative 7/2. If we wanted to, we could give that now as an interval. If we wanted to, we could give that in graph form. Which you'll be asked to do throughout the course of this chapter. Okay? So we got that. In terms of a compound inequality, which can be done, okay? Now, instead of what you do on one side, you do to the other side, now it's what you do in one section, you do in all 3 sections. Okay? Give you a couple of seconds here to write this one down. And then what I would do first here is I would multiply the middle by 3, because multiplying the middle by 3 gets rid of the fraction. But if I do that, then I've got to multiply the outer parts also by 3. So then that would become negative 9 is less than 2x plus 5 is less than or equal to 15. We want to get x by itself in that middle section. So I'm going to subtract 5 in the middle, which means I've got to subtract 5 on the outsides also. That then gives me negative 14 is less than 2x is less than or equal to 10. I want to divide by 2 in the middle, which means I need to divide by 2 on the outsides, which then would give me negative 7 is less than x is less than or equal to 5, which would be the inequality answer for that. The interval answer would be that. The graphical answer would be that. Okay. Yesterday, y'all got an assignment list. It was on a half a sheet of paper. Okay? So as of right now, we are basically through the first 4 sections of chapter P on your textbook. So if you want, you could do some of these extra problems to get your mind back into thinking of them. What you do is you go through on, so like on, it says page 9. So you would scroll down here to, come on down now, come on now. Where'd you go? There you go. To page 9, and there is the exam, or the homework problems to do it on page 9. So on and so forth. So that would be the start of where they are. And then all of chapter P is in there. If the it takes a while for it to load up. Okay? Still to be determined if we're going to collect anything. We will let you know on Tuesday in grading phase day whether or not we're going to collect